Okay, welcome to Inferential Statistics. Apologies, my voice is a little bit croaky. We'll see how we get on. So the time has come. We're going to be looking at inferential stats. So it's nothing to be scared of. You're going to be brilliant. I'll take you through the steps one by one. I guess the most important thing is that actually there's quite a bit of prior knowledge needed. There's a few pieces that we need to put together for the inferential testing puzzle. And so if you're not confident with hypotheses, experimental designs, and so on, then things will start to fall apart. And so it's your responsibility here to make sure that you're really confident with these areas of research methods. So this is the specification. I won't spend too much time on this because there's lots of language in here that you're not yet familiar with, but you will be experts on in no time at all. So when we're talking about inferential statistics or statistics in general, we need to have a pretty good understanding of what that means. So in research, we are often collecting quantitative data, meaning we're collecting numerical data. And once we've collected that, it's then important to summarize it numerically. If we are providing a quantitative summary, then that's called descriptive statistics. So last year in lower sixth, you would have learned about descriptive statistics. By descriptive statistics, we mean really three things. We mean measures of central tendency. So that includes your mean, your median, and mode. Your measures of dispersion or spread, and this includes range and standard deviation. And then also the reporting of general trends or characteristics. And quite often that's done using some sort of graphical displays like bar charts, pie charts, or what have you. And so these are the three ways that we use descriptive statistics. And they can be really useful to get a sense of or get a feeling of the data. So it allows us to take a whole range of data and to be able to get a really basic understanding of it. But descriptive statistics alone really don't allow us to make any conclusions or identify whether what we're observing is meaningful or not. Now, I'm using that word I guess incorrectly here, but we'll look at what I mean by meaningful or significant later on in this inferential testing topic. So when we're talking about inferential testing, this involves using statistical techniques, and that will tell a researcher whether their finding is significant or not. In other words, is the difference between the conditions in an experiment big enough for us to be confident that that difference is due to the IV rather than something else. If we're talking about a correlation or an association, is that strength of that correlation big enough for us to be confident that there is a relationship between those two covariables and that we haven't just seen something at random? Okay, so don't hold me to that language for now because I don't want to go into the specifics of what significance means, but that just gives you a general idea of what we mean by statistical significance and therefore why inferential testing is important. The reason it's important is because it ultimately is what allows us to determine whether our null hypothesis is accepted or our alternative hypothesis is accepted. Only one of them is true, and our inferential testing allows us to determine which one that is. So this looks a little bit like nonsense at this stage, but those of you that have done biology, those of you that have done maths will have come across some of these tests like chi-squared before. This is what we're working towards here, being able to choose the correct inferential test for our research. So we want to determine significance, we want to know whether to accept or reject the null hypothesis, and so in order to do that we need to run one of these inferential or one of these statistical tests. And how we've designed our research will inform which test we use. Some of them are more powerful than others. Some of them will find differences or correlations where others don't exist and so on. So it's really important that we're selecting the right test. So these are the names of the tests. We have a chi-squared, a sign test, and we have got chi-squared over here as well. Mann-Whitney-U, Wilcoxon, Spearman's Rho, the unrelated t-test and the related t-test, and then Pearson's R. Those will come with time. You really don't need to know any more than that. You just need to know the conditions that would lead you to select that particular test. The only test you will need to know how to calculate is this one, the sign test. And it's very, very easy, sort of ridiculously so. In psychology, you won't need to know how to do these other tests. You just need to know when to use them. Okay. So let's have a look then at the steps involved in identifying the correct test. We need to, first of all, identify whether our whether our research is a test of difference or a test of association. We then need to identify if it's a test of difference, and only if it's a test of difference. What is the experimental design? Are we dealing with unrelated data or are we dealing with related data? And then finally, we need to look at our level of measurement. Okay, in terms of the DV and what is being measured, or if you're looking at a correlation or an association, what are our covariables? They're both being measured. And that will lead us to the correct test. Okay, so I'm going to work through these one by one. We'll do levels of measurement in the lesson just because there's a few more steps involved in that one. But this video is going to focus on whether it's a difference or an association and whether data is related or unrelated. So let's start with test of difference or an association. Okay, so it's important to identify this factor first of all because statistical tests are designed to be used for one or the other specifically. So this has to be our starting point. Are we designing a test of difference or a test of association? Sometimes it might be obvious from the wording of the hypothesis if they give you one. The researcher is looking for a difference between males and females. Or the researcher is looking to see if there is an association between being the firstborn and career choices later in life, for example. But sometimes you're not so lucky. You're not given a specific hypothesis, so you need to work it out yourself. So, a test of difference. This is what we see if we've conducted an experiment. In an experiment, we manipulate an IV to measure the effect on the DV. And we compare the difference between our conditions of the IV. Typically, that's a control and an experimental condition. There might be more experimental conditions, but typically in a basic experiment, we are looking at the difference between our control and our experimental conditions. So that is our understanding of what we mean by difference, the different conditions of the IV, control or experimental. Sometimes we might not have a control, sometimes we might just have two experimental conditions. That's okay, they're still conditions of the IV. So let's have a look at an example here, and I've used the same example in both, just using different methods. So if we want to have a look at the impact of revision on exam scores, and we want to do this by doing an experiment and looking at the difference, then we're going to have two conditions, condition 1, condition 2. Condition 1, our control is given no revision support, and our experimental have been given additional revision lectures. And what we're ultimately going to do is see if there is a difference between their exam scores between those two conditions. I think it's very, very useful when trying to identify whether it's a test of difference or an association to just think to myself, or quite often I will draw this out, how would the results of this study be plotted on a graph? If it's a test of difference, i.e. if it's an experiment, if it's a difference, then we have two conditions. So we immediately know that this is going to be plotted via a bar chart where we have our first condition and our second condition, because what we're doing is trying to see if there is a difference between those two conditions on the DV. In this case, we're seeing if there is a difference in exam score percentage between those who had no additional revision support and those who had 3 hours. Okay, so if it's a test of difference, it means that we have different conditions, and we're looking to see if there is a difference between those conditions. A test of association is different. A test of association, there is no IV, there is no DV. Instead, what we're referring to here are covariables. We haven't manipulated anything, so there's no conditions of the experiment, and we're not measuring a DV. Instead, actually, when we talk about covariables, what we're doing is measuring both. We measure covariable 1, we measure covariable 2, and we see if an association exists. So if we just think, before with a test of difference and an experiment, we had different conditions and we plotted them using a bar chart. For a test of association, there are no conditions. So we're not going to have different bars to represent those conditions. Instead, we measure covariable 1, we measure covariable 2, and what we're going to be plotting is some sort of scattergram. So we measure both covariables. There's no dV that we measure, there's no IV we manipulate. It's just measuring those two covariables. So in the case of this experiment here we're looking at the relationship between revision and exam scores. And we measure covariable 1, and that's going to be the number of hours that a student revises. 1, 2, 3, 4, all the way up to 10 perhaps. And then covariable 2 is their exam score percentage. So for each of those participants, we're going to plot. They did 4 hours of work, and they got 80% or so on the exam. Okay. So a difference is what we see in an experiment, because we're looking for a difference between the conditions of the IV, control and experimental typically. And for an association, there is no IV or DV. We are looking to see if there's a relationship between those two covariables. Just a brief note here, and this is something that you should kind of be clear on from last year. The difference between a test of association or relationship and correlation. We can't use these terms interchangeably. These, yes, fine, but all correlations are tests of association, but not all tests of association are correlations. Correlation is a technical statistical term, while an association or relationship is not, okay? Correlations, for an association to be a correlation, the covariables must be continuous data. In other words, it can't be discrete data, it can't be categorical. It's got to be some sort of numerical data, right? It can't be males or females, okay? If it was males or females with categorical data, then we know immediately that it's a relationship rather than a correlation, okay? The next thing that's necessary for it to be a correlation is that the relationship is linear, right? It's got to be linear. There are associations that exist which are not linear. It might be, for example, curvilinear, or it might be like U-shaped. It might be something like this. We've seen these in psychology. For example, this looks like the serial position effect. This looks like the effect of anxiety on eyewitness testimony. And so we see, there's a relationship between anxiety and eyewitness testimony. There's a relationship between the order of words and percentage recall. But these are not correlations because that data is not linear. Okay. So that's what's necessary. That's all you really need to know. So please don't be using the term correlation unless it is indeed a correlation. Linear data and continuous data. Otherwise, use the term association or relationship. So just to recap before you pause this video and go and complete some of the activities on difference or association. A difference is when we use an experiment and we're looking at the difference between the conditions of the IV. An association, there's no IV or DV. Instead, we are looking to see if there is an association between two covariables. We measure both and we see if a relationship exists. So with that in mind, you have some activities, some PPQs for you to complete. Really important that you're practicing your justification. So it's not enough in inferential testing to just state. Half of your marks, sometimes even more, is due to your justification, and that's your application. So I want you really, really focused here on specific, explicit application to the scenario. Then once you've done that, come back and we'll continue on with related or unrelated. So in deciding on a statistical test, once we have identified that it's a test of difference, we then need to decide whether the data is unrelated or related. Note that if it's an association or relationship that we've identified, this isn't relevant, okay? We just carry on then to level of measurement. So when it's a test of difference and when it's a test of difference only, do we then need to go to this next step, identifying whether data is unrelated or related. So what we mean by this is the experimental design. And this is why it's only relevant for a test of difference, because in an experiment, we'll have an experimental design. In a test of association, there is no experimental design because it's not an experiment. So we need to decide if our study is independent groups, matched pairs, or repeated measures. As you can imagine, these terms related and unrelated refer to the participants in each that have been assigned to each condition, and it's fairly easy to work out. Related data is where participants in each condition are related in some manner. For example, matched pairs, they are related to one another because they've been matched on a key characteristic that's important. Repeated measures, they're matched because we're dealing with the same participants in each condition. So for both matched pairs and repeated measures, we deal with related data. Independent groups, this is unrelated because we just have different participants in each condition that bear no relation to one another. Okay, so fairly straightforward there. So that's fine, you guys can head off then, and you can complete, there's 2 activities here. I'd like you to read through these scenarios and identify what is the experimental design. Note that it won't necessarily be clear whether the experimental... no, never mind, scrap that, sorry. Experimental design out of independent groups, matched pairs, or repeated measures design. And then, based on that, is it related or unrelated? Then I'd like you to carry on and do the PPQs here. Again, really, really important for you to ensure that you are justifying your answer. So we need to, in order to justify it, say what is the experimental design? And then we need to apply that. How do we know that we're using different participants or the same participants? Make sure you're referring to the conditions of this particular study. All right, good luck.